Okay, last seminar we already looked into a correlation analysis and simple linear regression, right? So for a recap, right? For as a recap, so kita tengok for simple correlation analysis, we going to measure the relationship and the strength of relationship between two variables. And these two variables commonly known as independent variable and dependent variable, right? Boleh faham, ah? And these two variables should be numerical in nature. Means if you still remember in chapter number 1, I already told you the type of variable. We have two type of variable. The first one is a uh, quantitative variable. Another one is qualitative variable. Under qualitative variable, we have two measurement scale, which is nominal scale and ordinal scale. For quantitative variable, we have interval scale and ratio scale. So if you still cannot recall the type of variable and what is a measure scale of measurement, you should revise back your chapter number 1, right? And in this correlation analysis, independent variable and dependent variable should be numerical variable, means it should be continuous in nature, either interval scale or ratio scale, right? And you should know what is a dependent variable and what is independent variable. Dependent variable depend on independent variable, where independent variable works independently and does not depend on independent variable. For example, let's say smoking and risk of heart disease. How many cigarettes you smoke heart disease is depend on how many cigarettes you smoke. So heart disease is your dependent variable, and number of cigarettes smoked is independent variable, right? So by now, I think you already know how to differentiate independent variable and dependent variable. For correlation, we have three methods to measure the correlation or relationship between two variables. First is using a scatter diagram. We already looked at this method last lecture. And Pearson product moment coefficient of correlation, we also looked this one. We have looked this one last lecture. So for example, let's say let's revisit how to construct a Pearson product moment coefficient of correlation. Let's look at into Blue Moon Private Limited dataset. This dataset I already given to you. Right. So first step is we need to make sure our dataset is clear, right? Clean means others than variable name and data point kita kena delete lah. So others than means that kita tengok kat sini kita ada R&D. This is a short name kan, short name semua kita kena delete. We don't want this one. And then others than X $1,000. This is per scarf, per RM 1,000. Ni semua kita kena delete jugalah. We don't want. What we want in our data set is we want to have a very clean, which is first row should contain a variable name. Second row onwards should contain your data value. Right, this is the most important part. So to find correlation, we just go to data tab, like Excel, and we click on data analysis tool, right? So then we need to find correlation. So you need to find correlation in the dialog box and click OK. And input range, this is the input range yang kita masukkan lah, range mana yang kita nak masuk. Let's say from sales to until research and development, and we select all the data, right? Nampak tak? I select semua ni from B1 until E41. Okay, and then click here, and then dekat sini group by, this is by column or by row, dia tanya dekat sini. So kita tengok dekat sini, dekat data kita, kita adalah setiap variable kita adalah by column. So that's why we select by column. If our data set variable are setting by row, then we need to select by row lah, right? And then since we already we select the data including our variable name, that's why we need to click on label in first row. And then dekat bawah ni dia ada output option, click output range. Let's say where is the data dan kita nak result yang kita nak letak. So kita nak Excel bagi result kat kita dekat G2, right? And then click OK. So dia akan bagi result. So dia give us the correlation based on a triangle matrix. Lower triangle matrix. So lower triangle matrix means you akan nampak the value at the bottom. If upper triangle matrix means that dia bagi value dekat atas, dekat sini. Tapi if you want to know, this is the matrix yang sama lah, upper triangle value and is equal to lower triangle value. Means that advertising and sales dekat sini is also same as sales and advertising. The value should be the same. The value should be the same. Dia mesti sama. This one should be this one. Dia mesti sama. This one sama macam ni. Oh, yep. Dia sepatutnya sama macam ni lah. Dia mesti triangle matrix. So the value given in this matrix, for example, sales and expenditure, advertising expenditure and sales. So we have the correlation value 0.72. It means that we have a moderate positive linear correlation. If we have a negative 0.66 for sales and selling price, we have a moderate negative linear correlation. So that is how we do for a correlation measure lah. Right. So this is just a recap, a revision for last class. So now kita nak masuk hari ni, kita dah tengok last class kita tengok simple linear regression. Tapi dalam simple linear regression last class kita tak habis, right? So kita tengok simple linear regression again. So this is the simple linear regression equation. We have y equal to a plus bx, right? So where y is your dependent variable, x is your independent variable, and a is your y-intercept. Y-intercept means that when we draw a graph, okay, when we draw a graph, right, we have this is y and this is x, right? So y-intercept means that where is the intercept? So let's say the intercept dekat sini means is the point of A is over here. If this is a positive value, if A is positive value, if A is negative value, so point of A should be somewhere here lah, right? So they can intercept and then they can create either the straight line of either increase or decrease, right? So the formula, we are using a least square method, right? Least square method means there are banyak method, orthogonal method and so on, but we are focusing on least square method, right? So Excel also give us the value based on a least square calculation, right? So now kita tengok dekat sini, for a simple linear regression, let's say I'm using a Blue Moon data set, right? Simple linear regression, I delete this one first. So let's say I want to know the relationship between sales and advertising expenditure. Based on correlation measure here, we know that sales and advertising has a positive correlation, which is a moderate correlation. Let's draw linear scatter diagram dulu. Let's say let's draw this as a scatter diagram to show the relationship. No, now see, dia akan bagi macam ni. Let's say kita tengok, kita select data. So kita edit ni. This one I already told you last week. So X value should be advertising expenditure. So we select from here to here. Right? And Y value should be your sales. So we select all the data from sales column. And then we click OK and OK. So now kita akan nampak macam ni lah. So this is the relationship. Kalau kita tengok the correlation value given, we have a 0.72. So if you look at the scatter diagram, you can see that the value are increasing from left to right. Right? Means that this is a positive correlation lah. If you're not sure, then you can click on quick layout and find this one. So now you can see dekat sini I buang legend ni. Okay, nampak. So they already gave us the trend line. The trend line shows that it's increasing from left to right, means that it's a positive correlation. So we have a positive correlation between sales and advertising expenditure. So this one should be advertising expenditure. And then this x-axis, y-axis should be sales. Right? So this one, the relationship between sales and advertising. Right? So now I hope you got the idea, right? Because we already done this last lecture, and I already upload the recording lecture on YouTube. Kan you boleh tengok balik. So now let's say we want to know, we want to obtain this equation. Right, we want to obtain this equation and we want to do further analysis. Whether we want to know whether this model is valid or not valid, right? Whether we can still proceed with the simple linear regression or we should stop and do something else and method. Maksudnya guna non-parametric method, or you need to use only correlation. You cannot go for simple linear regression. We want to know that. Last class kita tak bincang ni. Sekarang kita nak bincang ni. Sekarang kita nak tahu sama ada model yang di-create ni, y equal to 0.46x plus 123.38 ni valid atau tak valid. Maksudnya kita boleh guna untuk prediction ataupun tak boleh guna untuk prediction. Maksudnya setiap model yang kita buat, bukan semua yang boleh pakai. Kadang-kadang kita kena tahu ada term garbage in, garbage out. Right? Pernah dengar yang isu terbaru berkenaan dengan swab vaksin tu, right? Tu kita tak nampak lagi dia punya artikel, right? Berkenaan dengan tu. So kita kena berhati-hati. So kita nak make sure setiap analysis based on data, kita kena tahu, kita nak make sure sama ada model yang kita create tu boleh pakai atau tak boleh pakai. Kita nak tahu this one. So now what we need to do is we want to create a linear regression, simple linear regression model. So we go to data and data analysis, right? And then we choose regression, right? Regression and click OK. So now x-axis, let's say kita ambil x-axis should be advertising expenditure. So I'm doing a simple linear regression, okay? So y-axis should be sales, right? And then we put label, because we are selecting based on from label, okay? From a variable name, we click label. Confidence level 95%, and we click only residual. We click only residual. And if you want, you can also click on normal probability plot. And I want Excel to produce the result down here, right? Where at G21. So I click OK, right? Dia akan bagi result kat kita. So from here, we know that multiple R is 0.72, which is also equal to the value of correlation. But in Excel, right, the multiple R doesn't care the positive and negative value, right? If you have a negative 0.66 here, which is a selling price and sales, if you run a linear regression for sales and selling price, the multiple R will only show the value of 0.66. It does not include the negative sign. So that's why we need to have a scatter diagram and a correlation measure, right? So this is the value of correlation. R squared means that 0.59. So dekat sini, mana draw? So this one, I ulang balik this one I dah cerita last week kan, last class. 0.519 means that 51.92% of the variation in sales is explained by this is advertising expenditure, right? Where another 49% are from others variable which is not included in the data set lah. Right. So remember, kita hanya untuk this step we only focus on sales and advertising expenditure. So I hope you pay a lot of attention in this subject, this topic, because next test number 2 will be all regarding correlation and regression. Right? Pay more attention. So we look into one-way ANOVA. This is ANOVA table. We look into significant value. So the hypothesis for ANOVA is null hypothesis, the model is fit for prediction. And alternative hypothesis, model is not fit for prediction. You can refer back to this in last lecture video, right? Since the p-value is less than 0.05, which is very small, right? We have dekat sini kita ada 0.00000001580. Right? Very small, which is less than 0.05, right? So it means that we're going to accept an alternative hypothesis, which is a model is valid for prediction, right? Remember, null hypothesis model is not fit for prediction. Alternative hypothesis model is fit for prediction, right? So since the p-value is less than 0.05, we accept null alternative hypothesis, which is the model is fit for prediction. So we can look into the third table. The third table, we're going to focus on the coefficient value first. The coefficient will be, this is y, this is where our equation is obtained. So y equal to, this is intercept is your A and this is your B. So y equal to 123.38 plus 0.4361 x. So if you notice here, dekat sini x value ni adalah positive, means that is parallel dengan yang kita dapat tadi. Maksudnya positive correlation. If the value of advertising expenditure coefficient is negative, means that it should be on negative side, right? Okay, now we're going to look into the T statistics. We are going to focus on advertising expenditure, right? The column, the second row dekat sini, right? We focus on the second row. So kita tengok dekat T statistics is 6.4, okay. And then the P value here is 0.0000015805. So kenapa sama? Right? So sebab sama because we only measure single variable. Right? We only measure single variable. That's why we're going to get the same value as ANOVA table. Right? Kalau kita ada multiple value, nanti kita akan tengok lepas ni, multiple value, we're going to see a different P value here. So, the null hypothesis here is beta 1 is equal to 0, beta 1, H not alternative, beta 1 is not equal to 0. It's not equal to 0 and equal to 0 means that there is no relationship between sales and advertising expenditure. For alternative hypothesis, there is a relationship between sales and advertising expenditure. Since the P value is less than 0.05, so we're going to accept alternative hypothesis, which is the value that we have there is a significant relationship between sales and advertising expenditure. So we already know that this value, this variable is significant. So next thing is we want to evaluate whether we can use the model or not, right? We can use the model or not. So macam mana nak evaluate whether we can use a model or not? So mana dia punya graph tadi kita minta? Okay, kita minta dia letak kat sini. Dia letak kat atas ni. Alright. So kita tengok kat residual. Residual ni apa maksudnya? Residual is, if you still remember my last lecture, right? So we have Y axis. Alamak. I tarik cantik-cantik sikit. Let's see. Y axis. And this is X axis. Right? Remember? Y axis is your sales. X axis is your advertising expenditure. Right? Oh, kita tengok yang atas ni lah. Senang, tak payah lukis dah. Kita tengok dekat atas ni. Okay, sini dah lukis siap. Okay, let's see. I buka besar sikit. Okay. Boleh nampak this is a scatter diagram and this is the line. The line yang kita nak, yang Excel bagi. So, line ni dengan observation ni. So, the distance, jarak line dengan observation. This is yang bulat ni observation kita yang real data, the real value. So, jarak ni kita panggil error. So, ini adalah error. Error 1, error 2, error 3, error 4 and so on lah. Ada banyak lagi kan. This is error juga, error yang distance ni, ni jarak-jarak ni kita panggil error lah. So, error dekat sini bermaksud residual. Error dalam Excel, dalam Excel, dalam linear regression we call as a residual. Predicted sales means that predicted sale is your line ni. Ini line ni. Line ni kita panggil predicted sales. Boleh faham Yang line ni adalah predicted line. Right? Yang warna titik-titik ni, ini yang dipanggil predicted line. Yang kita predict menggunakan this equation. Y equal to 123.38 plus 0.4362x. So this is your predicted value. And the distance between the predicted value and the actual data, this is the actual data, kita panggil residual ataupun error. Right? So, kita nak tahu sama ada the assumption is kita kena tengok, I tunjuk dekat you the slide, key assumption. So there are basically three assumption yang kita kena tengok, ataupun 4 assumption. Kita ingat satu lagi, L, I, N, E. L is for linearity. This is for independent. This is for normality. And this is for equal variance. Right? So kita ada 4 assumption line. So first assumption is linearity. Linearity means that we're going to measure the linearity assumption, linearity relationship between independent variable and dependent variable. So macam mana kita nak verify dia? Kita akan tengok kepada scatter plot XPYR. XPYR means that x-axis should be a predicted value, y-axis is your residual value, right? So if assumption is met, so kita akan nampak residual randomly scattered about 0. So dia akan scattered around the 0 lah. So kita nampak this is the 0, so dia akan scattered macam ni. So dia scattered around the 0. Kalau kita nampak bentuk lain, so dia bukan linear, right? So normality, so we're going to measure the normality based on the residual value. So we're going to do a histogram of the unstandardized residual, right? So kalau kita nampak bentuk bell-shaped distribution ataupun normal based on a box plot ni, right? Maksudnya the line should be at the middle, so maksudnya dia normal lah. Ataupun kita boleh guna goodness of fit test to measure the normality, such as Shapiro-Wilk regression test, Kolmogorov-Smirnov, Jacobera, kita ada banyak lagi, Anderson-Darling and so on. Homoscedasticity. Homoscedasticity means that we're going to measure the equal variance. So we still based on XPYR, so sama juga dengan linearity. Kalau assumption is met, there are no the variance are equal, so dia akan tabulate macam ni, mesti around the 0, right? So independence means that we need to make sure the data collection are independent lah. This is settled during study design phase. So this is an example checking for linearity and equal variance. So it should look like this, right? Yang first one, kalau kita nampak the curvilinear and macam ni, the quadratic macam ni, this is not a linear relationship lah. So kita tak boleh proceed dengan simple linear regression because this is not linear. We need to use another type of regression, such as a Poisson regression, Weibull regression, or a binomial distribution regression, such as a logistic regression, Probit, and so on. So there are a lot of regression out there. So we need to check whether we can proceed with the linear regression or cannot proceed. So we need to check the linearity assumption first. And then this is an example of non-linear relationship. So kita nampak dekat sini dia naik quadratic sikit naik atas, curvilinear, right? And then this is for equality of variance. Kalau kita nampak dia bentuk macam ni, the first one concave, right? So this is equal variance assumption is met lah. Kalau kita nampak macam ni, right? Dia membesar ataupun mengecil, right? So this is the equality of variance is not met. So not met, we cannot proceed with linear regression lah. Okay, now let's look at this one. Okay, so first one I want to create a check for linearity, right? Linearity, kita nak check macam mana. So linearity and equality of variance, we are going to check using XPYR. XPYR, we have P here, R here, means the residual is R, P is predicted value. XPYR means that we're going to select predicted sales and residual sales and click on scatter diagram. Right? So now dekat sini kita kena select data and click on edit. So X axis should be XP. It should be predicted value lah. Predicted value. Y axis should be residual value, right? So this is a yang betul lah. So let's say kita tengok this one. Okay, kita try adjust lah. This is from, let's say, 120. Okay, so kalau kita nampak dekat sini, this is the zero value. Nampak tak? This is the zero value. So the zero line here, right? So kita nampak dekat sini, the observation XPYR are scattered around the zero value. Means that we can say this model have a linear. This variable the residual is linear, and there is equal variance. So two assumption is met. Another assumption is we need to check for normality of the residual. So normality of the residual, kita select residual dekat sini, right? And then we click on insert. Now we choose for box and whisker plot. So kita pergi dekat histogram dekat sini, nampak tak dekat sini, histogram, and we choose box and whisker plot. So kalau kita nampak box and whisker plot dekat sini, dia approximate to normal distribution. Kalau kita nampak dekat sini, sepatutnya the middle line dekat sini, line ni sepatutnya duduk dekat tengah-tengah. So kita nampak dekat sini dia sedikit on the right, right? So dia ke kanan sikit, so means that is positively skewed. Tapi kita boleh kata dia kita tengok lagi kepada this one, normal probability plot yang dia bagi tadi. So kita tengok dekat sini, dia menaik. Tapi walaupun dia menaik macam ni, kita nampak dia skewed to positively. Dia tak betul-betul dalam straight line, right? Dia sepatutnya dalam straight line lah. So kalau dia ada around the straight line, means that is a normal distributed lah. Okay, so that's how we check for assumption untuk linear regression. Okay, boleh faham tak before we go for multiple linear regression? Ada soalan tak? Hello? Okay, good because yang ni kita dah tengok, kebanyakannya kita dah tengok last class, right? I just tambah dekat belakang ni saja. And then now lepas ni kita nak tengok multiple linear regression. So before we go for multiple linear regression, I suggest we take a 5-minute breaks, right? Okay. Sekarang pukul 11.33, kita akan jumpa balik 11.42. Alright, can we continue?
Okay, boleh.
Alright, so now let's look at into multiple linear regression. So just now we already looked into a simple linear regression. So multiple linear regression means that is an extension of simple linear regression where there is more than one independent variable to be included into the model. So kalau kita tengok tadi, we only include a single variable, which is advertising expenditure, right? So to create a multiple linear regression, we need to test for every variable with a single linear regression. So we need to test whether all the variable are significant or not. For example, let's say I'm using kita tengok for selling price pula, right? So kita tengok selling price, X range, kita select selling price, right? And then letak dekat, let's say kita letak kat bawah ni pula lah, letak kat bawah. Okay, and then kita klik OK. So now, dah nampak dekat sini selling price, dekat P value dekat sini, selling price is significant, right? Means that there is a significant relationship between selling price and sales. So we already know advertising expenditure and selling price is having a significant relationship towards sales, right? And then we try to do the last one, which is research and development. We need to test. We need to make sure all the variables are significant, right? So let's say I select X range should be research and development expenditure, right? So I put here dekat bawah ni pula, right? So letak kat bawah. So kalau tengok dekat sini, the P value also a significant, right? So means that we can proceed with a multiple linear regression with including research and development expenditure, selling price and advertising expenditure. Kita boleh include yang semua lah. Kalau tak, kalau ada yang variable yang tak significant, maybe kita boleh include juga, but we need to check if the P value is more than 0.25, means it's very high, we should exclude that variable into from a multiple linear regression, right? Okay. So now, for multiple linear regression, we click on data analysis and click on regression, right? Y axis we select for sales. Semua variable sales ni kita select, right? X axis kita select semua ni, advertising expenditure, selling price and research and development. Nampak tak? I besarkan sensor dulu. I besarkan bagi you nampak, right? So I click on data analysis and click on regression. Step yang sama. Instead of selecting one single variable, I say Y axis, kita select sales. Right. For X axis, kita select expenditure, advertising expenditure, selling price, research and development until semua ni lah sampai 41 ni. Kita select semua. So nampak tak I select semua? Macam sama juga macam I select correlation tadi I buat. So label I biar label, confidence level 95% and then output range kita letak, let's say I nak pilih dekat tempat bawah sikit lah. Dekat sini I nak letak kat sini, okay. Dekat B230. So I click OK. Residual semua I letak OK. Apa jadi? Okay, let's say letak kat sini lah. Okay. Jadi boleh tak? X-ray more Y-ray must have a same number of row. Okay. Oh ya, dekat sini I terselect 2 kali. Kita cancel. Okay. And then baru kita dapat lah the value dekat sini. Bawah. Okay. This is the value. I berhati-hati untuk select tadi. So now dekat sini dia bagi dekat kita, multiple linear regression. This is R value 0.83 and R square is 0.69. 0.69 means that apa yang kita boleh kata dekat sini, 0.69 for R square is 69.46% of the total variation in sales are explained by apa? Kita tengok dekat bawah ni. Advertising expenditure. Lagi kita ada apa? Selling price and research and development expenditure. Ini dia punya explanation lah. 4R squared. So we have 40 observation and now we look into ANOVA. The significant p-value for ANOVA, the alternate null hypothesis, the model is not fit for prediction. The same interpretation, right? Alternative hypothesis, the model is fit for prediction, right? So since the p-value is less than 0.05, this one we have 0.0000, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here. 1, 2, 3, 4, 5, 6, 7, 2, 8, okay, 2, 1, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, correct. So this one. So very small, which is less than 0.05, right? So we can conclude that the model is fit for prediction. So now, let's look at the third table. We have a coefficient table. In this coefficient table, we look at the first column. So we have y equal to 179.95, which is the first one, y-intercept this one, right? And then plus the advertising expenditure 0.2308 x1 plus selling price pula. So selling price here is negative kan, so we need to put the negative sign lah. So you letak negative minus 5.1657 x2, and then for research development we have plus 2.7649 x3. So we need to explain x1 is advertising expenditure, x2 is selling price, x3 is research and development expenditure. Right, boleh nampak tak? Boleh faham tak? Hello? Okay, good. Boleh eh? Okay, good. So next step is we need to check for the linearity and the equal variance. So we're going to plot using XPYR. So now let's say kita select predicted value and residual value. We click on scatter diagram and make sure your data set dekat sini selected data, edit, X value should be XP, predicted value, Y value should be residual value, right? And click OK, right? So kita nampak dekat sini macam ni kan? Okay, let's say kita select Y axis, X axis ni, kita letak kat sini. And then kita letak 120 contoh. Kita nampak bajet-bajet lah 220 mungkin kat tengah-tengah ni kan. So dia nampak macam ni. So this is the XPYR plot. This is XPYR ataupun predicted value versus residual value. Right. So based on this predicted value versus residual value, we can say that the residual have a linearity assumption is met, then equality of variance also met because the value scattered around zero. Maksudnya dia scattered around zero lah. And then kita tengok normality. So for normality, we just going to select insert. Let's say kita ambil box plot. Tapi kita select this one dulu lah, residual. Residual, to select box plot. So based on the box plot, letak kat bawah ni. So this is normality of residual. Right. So based on the box plot, kita nampak dekat sini, the middle line is dekat tengah-tengah ni, this is represent median kan. Median is on the middle. So we can say that there is a normality of the residual. So normality assumption is met. So another assumption we need to check is the linearity of the covariates, right? So itu step yang sama macam residual versus predicted. So basically that's all for multiple linear regression. Okay, ada soalan tak? Ada soalan tak untuk multiple linear regression? Soalan?
Sir, sorry sir, yang predicted sales dengan residuals tu tadi,
Ya.
untuk buat dia punya scatter tu, yang X tu yang mana tadi sir?
Kita kena ingat XPYR. XPYR means that X is
predicted.
X is the predicted.
Right. Okay, sir.
Y is residual.
Okay, got it sir, thank you.
Okay. Just ingat XPYR. So this is for linearity and equality of variance. Okay? Boleh Okay. So I think we have done for multiple linear regression. Kita dah habis, right? So kalau kita tengok dekat sini, I've plot multiple linear regression, right? Kalau nampak, oops, I kena change the. You boleh nampak the slideshow? Slideshow yang buka besar-besar nampak
Boleh nampak.
Right.
Nampak.
Alright, good. So tadi I buat tadi residual versus predicted, kan? You nampak macam ni kan? And then I buat a normality plot, unstandardized residual. So kita nampak this is a normal assumption is met. This is for linearity and equality of variance. Right, so kita nampak this one dia scattered around zero. Maksudnya dia linear and equal variance. And dalam multiple linear regression we have five assumption. So remember tadi I sebut line. Line is for simple linear regression. This is for linearity, independence, normality, equal variance. So we only check for 3. And for independence, we should settle during a study design or data collection phase. And in multiple linear regression, we have added another one assumption, which is I. This is what we call as independence or linearity. Linearity of independence variable. This is a linearity of independence variable. How to check? We're going to check based on XP, YI. So kalau kita tengok dekat sini, ada letak saya punya, XI, YR. XI, YR. So independence of numerical variable, we want to see the scatter plot between residual and predicted value, which is XI, YR. So XI, YR ni, kita nak tengok the linearity of the independence. XI, YR. This is XI, YR. Right. So maksudnya kita akan plot X is our actual value, and Y is residual. Right. Macam tu kita akan buat untuk advertising, selling price and R&D lah. So kalau dia punya data is scattered around zero, means that there is a linearity assumption lah. So linearity assumption for independent variable are met. So maksudnya kita tak perlu tukar dia jadi categorical, kita tak perlu tukar type of data. So kita kena ingat kita buat linear regression, multiple linear regression. We need to make sure each of the variable are linear. So how to make sure? We need to do this plot lah. Untuk multiple linear regression kita kena buat this plot for advertising expenditure, selling price and R&D. So kita kena make sure dia scattered around zero. So kalau dia scattered around zero means that they linear covariates. So we can proceed with multiple linear regression. Alright. So I think that's all for multiple linear regression. So now sekarang nak masuk pukul 12. Kita nak masuk the second last topic, which is forecasting. So on forecasting, we will learn two methods, which is the first one is moving average method, another one is exponential seasonal smoothing method. Right. So before we proceed, do you have any question for the previous topic, trend line and linear regression? Soalan tak? Tak ada soalan? Tak ada, good Alright. So tak ada soalan ni, ada dua je possibility. Either you fully understand or you don't know anything. Right? You tak faham langsung. So you tak faham langsung pun tak ada soalan juga. Kalau you fully understand, you faham semua. Itu ada soalan. Right. Okay. I think kita rehat sebentar sebelum kita masuk a new topic, which is forecasting, time series analysis. Time series analysis, we have 45 minutes to finish up. But I'm not going to cover all. I'm going to split this topic into two. Then second half you need to study by your own, by using books. Right? Kita rehat 5 minit dulu. Boleh? So 12, 5 minit kita sambung balik. Okay?
Okay, sir.
Right. This is very short topic. Right? Forecasting. Introduction. Many business data measured with respect to time lah. For example, in sales, kita measure by day or by month or by quarter, right? So data occurring with respect to time is known as time series data, right? So sales, profit, revenue of the company is recorded for some years, month, quarter, some example of time series data lah, right? So time is taken as independent variable. So in time series data, time is taken as independent variable, while other variable is taken as a dependent variable. Right, such as sales, we want to project what is the sales for upcoming month or upcoming quarter. So we are using sales as our dependent variable, and independent variable is taken as time. So time can be taken as years, quarter, month, week, days, and etc. lah. So the best way to show the time series is known as time series plot lah. We can use a line chart to show the trend of the series, right? Whether it is increasing or is a seasonal effect or cyclical effect, and so on. So up and down time, this up and down of time series data is mainly due to 4 components. So 4 components in time series are known as trend data, seasonal variation, cyclical variation, and irregular or random variation. So let's look at the component of time series, right? So we have 4 component of time series, which is TSCI. T is a circular trend or trend variation. S is a seasonal variation, cyclical variation, and irregular variation. What does it mean by trend, seasonal, cyclical, and irregular? Trend is increasing, is a long-term movement in time series data. It's a long-term movement. Maybe it will take years or years or more than 1 year lah. More than 1 year to show the trend. So if you could look at this plot, kita nampak ni trend dia makin menaik time in years. So the sales makin lama makin naik. So dalam time series, we have up and down value lah. Sometimes it's up, sometimes it's down, sometimes up, sometimes down. Ada yang naik, ada yang turun. It's a nature of business lah. Ada naik, ada turun. Tak selalunya semua akan naik saja. Tapi overall we can see the trend whether it's increasing or decreasing. Right? For example, trend and increasing number of HIV cases in Malaysia from year to year, and increasing of number of road accident death from year to year. So this is a long-term movement, right? For seasonal variation, it's a short-term movement. Short-term movement in time series usually occur within a fixed time period of 1 year. Dalam 1 tahun ni dia ada up, down based on the seasonal event. So for example, increasing sales bus ticket during festive season. So sebelum COVID cases kan. So kalau kita nak balik raya, okay, bus ticket semua sold out. Lepas tu bus ticket down. Contoh lagi satu macam orang pergi kerja balik kerja. Traffic, number of traffic on the road from 7 AM to 9 AM. So the number of traffic jams or number of car on the road very high. And then dia akan slow down pukul 10 sampai pukul 11. And then pukul 12 dia sampai pukul 1, pukul 2 tu dia akan naik balik sebab time rehat. Pukul 4.30 hingga pukul 7 orang balik kerja. So dia akan mula penuh balik. So this is based on seasonal effect, right? So increasing sales of school uniform during the school holidays, the number of people in KLIA during Haji season, Hajj season, right? So this is a seasonal effect lah during 1 year, 1 tahun. Cyclical effect is a long-term movement in time series, right? So during it repeat over a time period of differing length, usually longer than 1 year lah. It's same as a seasonal effect, but seasonal effect is in 1 year, during occur in 1 year. But for cyclical effect, dia berlaku lebih panjang daripada setahun. Contoh macam declining of share price due to economic recession. Economic recession normally happen in 10 years time kan. So setiap 10 tahun dia akan economic recession. This is a normally predicted prediction lah kan. Decreasing employment rate due to economic downturn, pandemic era. So nowadays a lot of people have lost their job, right? Lost their income due to a pandemic era. And then this will happen pandemic season ni dia jarang sekali berlaku. Dia bukan 10 tahun sekali. Dia dinamakan sebagai irregular or random variation, right? Sebabnya contoh a loss of $1 million due to fire which caught the company last week, right? So Kita nampak dia punya trend ni, dia turun sekali and then dia keep on increasing balik. Dia akan balik ke asal tapi dia akan ambil masa yang lama jugalah. Right? Contoh macam sekarang punya condition, COVID, pandemic season, right? So it's never predicted to be this kind of pandemic. So a lot of people close their shop, right? Lost their income. So tapi lepas pandemic this pandemic clear, so dia akan balik ke normal. Tapi dia bukan balik ke normal cepat, dia akan slowly up to their stable rate lah, right? Another term we can there is another term which is a random shock. Random shock means that the line random shock. Contoh I draw. Let's say I create it's a new random shock. Let's say we have time series data and then dia tiba-tiba jatuh and then naik balik kepada asal. This is a random shock. This is what we call as a random shock. Random shock means that, so for example macam contoh dulu kan ada bersih kan, macam demonstration. So suddenly kedai tu okay, penjagaan stabil and then tiba-tiba ada demonstration, they should close their shop for that day. Satu hari saja sales akan turun. And then the next day sales macam biasa. So this is what we call as a random shock lah. Right? So measure of forecasting accuracy. So when we want to do a forecasting, we want to predict for the future, right? Based on the past data, we need to choose the best model that can fit to the data and predict the data well or forecast the data well. So to choose the best model, there are a lot of models available, such as a moving average method, least square method, seasonal variation, right? Seasonal smoothing, exponential smoothing, right? So when we want to compare the model, we need to choose the best model that have error, the lowest error. So for the three common measure, such as mean absolute deviation, right? Mean absolute deviation, mean square error, right? Another one is mean absolute percentage error, MAPE. Right, so we base on this measure. When we choose, then we choose the lowest error, and that model will be the best fitted model to forecast. Ya, kalau nak pilih model yang bagus, pilih yang ada error yang paling kecil. Right. So this is the calculation for measure of forecast accuracy. You can refer the formula in your book. Right, dalam buku dah ada formula ni ya. So for mean absolute deviation, so forecast error divided by number of forecast value. So forecast error means that actual value minus forecast value, right? Predicted value. Sama juga untuk mean square error, actual value minus forecast value squared divided by number of observation. Right, so now let's look at a moving average. So moving average is very famous method. Even in stock market pun kita menggunakan moving average. Kan? So pernah dengar moving average sebelum ni? So moving average means that we have a data. Let's say we plot the data. I plot the data. We have this kind of data. So moving average, let's say kita akan create satu lagi predicted value, which is dia akan moving. So dia akan moving sikit. So maksudnya dia akan base kepada past data. They can predict for the next coming season or next coming quarter, next coming month. So what is the predicted or forecast value, whether dia akan naik atau menurun. So this forecasted value is a non-linear line, right? So dia akan naik menurun lah. So dia takkan straight line macam ni lah. Sometimes dia akan naik turun macam ni. So dia ikut pas data lah. So in moving average, we can measure either 3 moving average or 5 moving average or 4 moving average, depending on how many days or quarter or month that we want to predict, right? For example, let's say we try to open a stock market. You familiar with the stock market punya condition? Let's say I buka trading view. Let's say kita tengok satu stock di pharma. Okay. Oops. Let me clear this one first. So kalau kita nampak dekat sini, this is a stock. Setiap satu ni dipanggil candlestick lah. Tapi we ignore the candlestick first, right? Kita tengok line ni. Line biru ni represent apa? 5 moving average. 5 moving average, kita nampak dekat sini. This is based on 5 days punya trading market lah. Trading days. So kalau kita nak tengok, okay, dalam masa seminggu, berapa dia punya performance, right? So kita nak tahu the next day dia akan naik ke dia akan turun. So kita nak tengok based on moving average dalam masa 5 hari trading days, right? So dalam stock market Malaysia ni kita 5 hari saja kan. So that's why kita tengok 5 hari. Kalau kita nak tengok dalam masa sebulan, let's say dalam 1 month we have 20 days trading day. So kita tengok warna merah ni. Okay, merah ni adalah representing 20 days, 1 month. Warna ungu ni 50 days. 50 days means 2 month lah. 50 hari. So kita nak tengok, okay. Sekarang ni stock dekat mana? Oh, stock dia punya price, our price is down. Bawah daripada 2 bulan punya average. Bawah daripada sebulan punya average. Dalam masa seminggu pun, oh dia bawah lagi. Dia baru bawah. Oh, so maksudnya stock ni mungkin dia akan continue turun ataupun dia akan naik sikit. Kita tak tahu lagi. Tapi based on this data, we can say that kita tak boleh beli lagi ni. Kita tunggu dulu. Tunggu dia cross naik baru boleh beli. Contoh macam tu. Kalau contoh macam ni kita tengok sikit. Kalau dia cross over more than a moving average, 5 day moving average, the next day kita nampak dia naik. Okay, dia akan naik. This is based on moving average lah. So we are predicting kalau dia atas daripada moving average, maksudnya dia bagus. Dia akan mula naik. Kalau dia bawah daripada moving average, means that dia akan turun. The price will decrease. Contoh, this is applicable lah for moving average method. So now we look into Excel pressure cooker sales. Excel pressure cooker sales. Dia boleh download dalam U-Future. Tiba-tiba I masuk trading punya ni pula. I just want to make sure you understand, right? Alright. So now to do a forecasting, we need to make sure we have a time series data, this is our independent variable, which is time. Our dependent variable is unique sold. We want to forecast for day 25. Kalau you tengok dalam buku, dia salah buat. Jangan tersalah buat macam buku tu. So let's say kita try to plot the data first. Plot the data, insert, and then we go for line chart and click on line, right? So kita ambil this one, kita padam lah. Okay, so this is the line, right? Line chart, actual sales, right? Actual sales. So kita nampak ni dia stationary lah. Masa stationary ni dia adalah satu, dia tak tunjuk trend langsung, right? Dia tak tunjuk trend menaik ke menurun, kita tak tahu. Dia tak ada trend menaik ataupun menurun. Dia hanya static, stationary lah. Dia akan main, dia unit sold dia antara 150 to 200 macam tu, right? So now we want to do a moving average. So first we need to go to data tab and click on data analysis. Alright, data tab and data analysis, and we click on forecasting. Where is forecasting? Sorry, we click on moving average. Moving average. moving average and click OK. Now, input range, we need to select the unit sold sampai bawah. Boleh? Ada soalan tak sekat ni? Sampai 27 lah, sampai 27 lah. Sampai 28, 27. Maksudnya sampai sini lah. So, ada soalan tak sekat ni? Okay. And then click OK. And then dekat sini, since kita select, sekejap, I select label tak? Right, what happened? Okay. I ulang balik kita pergi ke data tab and click on data analysis, right? Right, so then kita choose moving average and click OK. Now input range, kita select from unit sold to 27, 155. And then label in first row, kita click on label on first row because I already select label in first row. So interval here, let's say I want to measure 3 moving average. Based on 3 month, apa dia punya moving average. So kita nak tengok for the next 3 month, so dia average dia atas atau bawah. Kalau bawah means the sales is not good lah. Kalau atas the sales is doing well, macam tu. So kita letak 3 lah for range, interval, moving average. For output range, kita letak kat sini, letak kat sebelah ni lah. Sebelah unit sold, dekat 188. So kita akan dapat, kalau kita nak chart output pun boleh, standard error pun boleh, right? Tekan dua-dua and click OK. Now, kita nampak dekat sini, sekejap. I think I make it doing wrong lah. Bukan macam ni Tadi kita letak kat 188 kan. Sepatutnya letak dekat unit sold ni lah. Alright. Okay, sekejap. I ulang balik semula. Data analysis, moving average. Okay. And then yang ni output range ni, yang atas ni betul. Output range ni I letak daripada atas. C3. Kita kena make sure kita tempat kat mana kita nak letak benda tu kan. So letak kat sini unit C3 and click OK. So now then baru nampak OK lah, baru nampak betul. So now kita nampak dekat atas ni adalah ini dikatakan sebagai forecast moving average. This is what we call as 3-month moving average. Right? So NA ni biasa, memang betul. Right? And then kita ada, this is forecast error. Oh, so this is not a forecast error, this is a standard error. Standard error, right? Standard error. So now kita nampak kat sini NA ni kita letak sama dengan letak dash. This is dash, okay? Dash. Right. So macam mana dia buat pengiraan ni? Dia buat pengiraan macam ni. This is the correct one. This is the correct one. This is not correct one. Alright. Macam mana dia buat pengiraan? Dia ambil tiga value ni 88 plus 144 plus 160. Dia akan tambah semua ni and then bahagi dengan 3. So dia akan dapat this one. Maksudnya dia akan ambil average of this one. Right? Kalau yang bawah ni dia akan turun 3 lagi. Lepas 188, 144 turun ke bawah. Yang lain, dia akan turun lagi. This is the correct one. Kalau dalam buku, dia ambil dekat sini kan, dia akan dapat yang seperti yang mula-mula saya buat tu. Right? But this is not, this is the correct one lah. Dalam buku tu salah, okay? Take note lah, dalam buku tu salah. So now we can see the moving average. And the moving average never complete, right? Tak habis. This is the, what we call as trend. So how to forecast? How to forecast? So forecast, kita kena tengok, let's say this is too much dia punya value dia, banyak sangat decimal. So let's say I make it 2 decimal point lah. 2 decimal point, so senang nak kira. Alright. So now, remember our formula, our component in time series, TSCI equal to Y. Right? So now, to calculate this value, right, or this value, we want to know, let's say, month 25, right? We cannot simply know the value of Y here, Y25, or if you want to find Y for 26, Y26. We need to create or calculate a seasonal variation effect. So to calculate seasonal variation effect, we need to create another table lah, to calculate seasonal variation. This is not covered in this subject. We just want to know the trend value saja, right? So there is going to have another cost of calculation lah, right? But it's not very hard to calculate. You can refer to my YouTube channel on time series analysis, part B. So I already shown how to calculate to do a predicted value, right? So in Excel, we cannot calculate 4 moving average on the odd numbers. We can only calculate 3 moving average, 5 moving average, 7 moving average on the odd number saja. Yang even number kita tak boleh. Even number 4 moving average, 6 moving average, 8 moving average cannot. We can only calculate for odd number, 3, 5, 7, 9, and so on lah. Right? So if you calculate for even moving average, let's say for example 4 moving average as shown in the book, which is wrong, right? So I don't know why they letak the 4 moving average, which is the wrong calculation lah. Dan dalam buku page number 131, so you tengok figure number 7.4, that one is a wrong moving average number, and 4 moving average also wrong. Right, so so you need to base on my calculation, okay? My method of calculation. Let's say kita nak buat 5 month moving average. Let's say I letak kat sini lah. Okay, 5 month moving average. Nanti letak sebab nanti nak kena tukar kan. So I letak data analysis. So moving average. Instead of data yang I select tadi, instead of 3, I letak 5. Now I nak letak dekat sini, dekat D3. So I click OK. Standard error I tak mau lah. Chart output pun I tak mau. Okay, click OK. So apa yang dia buat dekat sini, dia akan ambil 5, dia akan letak kat tengah. Right? So this is the correct one lah. Okay? Ada soalan tak? So this is how we do a moving average method. For exponential smoothing moving average, so you can refer to the book and try to do it, right? Example page number page number 134, right? How they do exponential smoothing with trend, right? Okay? Ada soalan tak before we end our session? But before you end, you tutup kelas kita, make sure you sign in your attendance. Don't forget that. Okay? Ada soalan tak? Hello? Ada soalan tak before we end our session?
Tak ada.
Right, I hope you understand. This session are recorded, so nanti you boleh refer back to my YouTube channel. I can post it in my YouTube channel. Okay, I think that's all. I hope you enjoy for the last 5 seminar ni. So this is our last class, and please complete all the assignment, all the tasks I given to you. And I think that's all. Thank you very much. Assalamualaikum.
Salam. Thank you, sir. Thank you so much.